What is up, math students? I am happy to be back teaching you yet another lesson from chapter 11, section 11.1, about integer operations. All right, so hopefully you guys have enjoyed the last few lessons. Don't forget to like and subscribe. JK, that does not matter. All right. What I do want you to do is to pay attention. All right, because today we're going to talk about integer operations, kind of going back to order of operations days, and hopefully this is an easy lesson for you guys. So let's go ahead and start by giving you something that you can definitely copy into your notes. All right. A mathematical phrase is made up of numbers and operations. Is called a numerical expression. Numerical expression. So this is something new for you guys. If you want, you guys can go ahead and pause. Take a second to write this down. This is in your book on page 504 if you guys need to, and make sure you have this in your notes. And we're going to talk about numerical expressions. And numerical expressions are often whenever you have only numbers and operational signs. Like an example, what is 5 plus 3 minus 2 times 5 plus 3 divided by 8 plus 0 times 0 equal to? Well, there's a lot of stuff going on in this problem. But this is just an example of a long numerical expression. And how would you know how to, what order to do this problem in? Like, some people might go 5 plus 3 is 8 minus 2, then multiply by 5. But that isn't the best way to handle this. And that, in fact, there are a lot of people who would get problems like this one wrong. So mathematicians have came up with a specific order called the order of operations in order to solve these problems. See what I did there? In order to solve these problems? All right. So the order of operations in our class, I've always said it is GEMDAS. All right, GEMDAS, and this is a little acronym to kind of help us remember the order of operations, where each letter represents a different word or phrase that might help us keep in mind what order to do these things in. G stood for grouping symbols. So if you ever had any work to do within grouping symbols, then grouping symbols was parentheses or exponents or fraction bar or square root or absolute value, now that we've talked about it. There's a lot of different grouping symbols that fall into this place. All right. So if we ever have any grouping symbols, we do the work inside of those first. Then we look for any exponents, and we try to apply any exponents. And kind of important for us, multiplication and division, all right, those two I put an arrow underneath, because whenever it comes to multiplication or division, all right, when it comes to multiplication or division, we have to do those left to right. Meaning, you can do multiplication or division first, whichever one shows up on the left. All right, and then you just keep working left to right. And the same thing applies for addition or subtraction. That also applies left to right. So I went ahead and just kind of remind you guys, I highly encourage you, whenever you have problems like this on your homework paper in your notebook, which you're keeping all of your homework notes on, write this at the top of your page. Refer to it as often as you need to, and the arrows underneath the multiplication and division, you do those together. And addition or subtraction, the same thing. Let's go ahead and look at a few examples that use this. Order of operations. Now notice I went ahead and wrote this at the top of the slide because I want to have this present for any type of problem I might have to solve. Evaluate. 18 minus 12 divided by -4. Now, I check my order of operations. Do I have any grouping symbols? And you would say yes. But is there any work to do within the grouping symbols? I would say no. -4 is -4. There's nothing I can do to simplify this, so I move on. Do I have any exponents? No exponents that I see. Do I have any multiplication or division? Well, yes, I do. I do have multiplication or division. So in this case, I can go ahead and divide. Okay, what is negative 12 divided by negative 4? Well, negative 12 divided by negative 4 is the same thing as positive 3. So 18 plus 3 is all we have left over. 18, and all of this is 3. And 18 plus 3 is 21. So if I follow the order of operations, I can clearly move through this, and I have a way to do this. Now notice, I didn't just do the first thing I saw. And if in fact you type this into a calculator and you have the wrong type of calculator, you would actually get the wrong answer. A calculator is just a tool that's going to do whatever you tell it to do. And if you tell it to do things in the wrong order, then you're going to get the wrong answer. So that's why it's important to follow our order of operations. Let's look at another example. Example 2. Simplify, and they want us to follow the order of operations. So, looking at our order of operations, do we have any grouping symbols? I would say yes. Is there any work that I can do within the grouping symbols? I would say yes. I can subtract 9 minus 4. 9 minus 4 is 5. And then I just copy everything down exactly the way that it was. The negative sign stays the same. The 6 stays the same. The plus stays the same. The 9 minus 4 becomes a 5, and the negative 3 inside the parentheses stays the same. All right. Do I have any grouping symbols? Yeah. Can I do any work within them? Nope. So I'm done with that. Do I have any exponents? No. Do I have any multiplication or division? I would say yes. So what is 5 times negative 3? Well, there's only one negative sign, so the whole thing is negative. And 5 times 3 is 15, so I end up with that. And now I have negative 6 minus 15. Now if you remember your rules for whenever you are trying to subtract, all right, you can go ahead and look and you can see that they are the same sign. The same sign means you're going to keep the sign whenever you add or subtract. And you're going to go ahead and add the values. Negative 6 minus 15 is negative 21. Think about it this way. If you owed me $6 and then you borrowed another 15, then you would have to eventually pay me back $21. Everything became more negative. Another one, and hopefully this is going to make a little bit more sense the more practice you get done with it. We check for any grouping symbols. All right, so yeah, I have a grouping symbol, but there's nothing I can do inside them. Do I have any exponents listed? No, there's no exponents. Do I have any multiplication or division? Yes. From left to right, I can multiply 8 times 3, which is 24. So 24 minus negative 10 divided by 5. All I did was copy everything down exactly how it was. Now, do I have any more multiplication or division? I would say yes. I have a division problem right here. Negative 10 divided by 5 is the same thing as negative 2. So now I can go ahead and copy everything back down. 24 minus negative 2. If you remember our rules, whenever we have two negative signs right next to each other, they make a positive sign. And this becomes 24 plus 2, which is 26. The old saying goes, how would you eat an elephant? One bite at a time. So my advice for you when it comes to problems like this is how would you solve a long, complicated problem like this? Well, one step at a time. All right, it just takes one step at a time. Let's go ahead and look at example 4. A lot of examples that kind of help us with all the practice we need for problems like these. All right, so grouping symbols. Do I have any grouping symbols? Yes, I have two sets of grouping symbols. So 5 minus 14 If you have $5, but then you have to pay somebody $14, you're going to be in negative amounts. This is going to give you -9. So I have -9 divided by 3. And then 2 minus 6 is the same thing as -4. So I have this. All right, so I've done all my grouping symbols. Do I have any exponents? I don't see any exponents, no exponents. Do I have any multiplication or division? Well, yeah, I have -9 divided by 3, and I also have 3 times -4. So which one do I do first? Well, the arrow reminds us that we're supposed to go from left to right. So the first multiplication or division problem that I see on the left is -9 divided by 3. They are two different signs. There's one negative sign. The whole thing is negative. 9 divided by 3 is 3. So -9 divided by +3 is -3. And I have to go ahead and multiply it by -4. There are two, so let's go ahead and circle our signs. We have 2 negative signs, so the whole thing's positive, and 3 times 4 is 12. The answer is 12. Cool? Cool. All right, a healthy reminder for you guys that grouping symbols include a lot of different things. There's a lot of different things in grouping symbols. So part of grouping symbols are fraction bars. Exponents are considered grouping symbols. Square roots, absolute value symbols. All right, these are all different grouping symbols. Also, just remember your regular normal grouping symbols also include things like parentheses or brackets or braces. All right, these are all special grouping symbols that we should kind of pay attention to. So let's look at a problem that deals with grouping symbols. All right, so simplify all of this, and this looks exceedingly complicated. It looks like it's getting worse and worse, but how would you eat an elephant? One bite at a time. And how would you solve a problem like this? One step at a time. Do we have any grouping symbols? Yeah, we have this guy, this guy, this guy. There's a lot of them. So one step at a time. 4 to the power of 7 minus 5 is 2, plus 7, and 5 plus 1 is 6, divided by 6 minus 9 is -3. Now they ask for the absolute value of that, so we're going to go ahead and keep that intact. Now, do we have any more grouping symbols to simplify? Well, technically we do, because fraction bars are grouping symbols. So this is still going to be 4 squared, plus 7 times 6 is 42, divided by the absolute value of -3 is just going to be +3. Cool? Next. All right, we still have a group. Now let's go ahead and say we're done with grouping symbols. Let's apply our exponents. We do have an exponent. 4 squared is the same thing as 4 times 4. 4 times 4 is 16. Because remember that whenever we have this is the same thing as 4 times 4, and 4 times 4 is the same thing as 16. So 16 plus 42 divided by 3. 3 can go into 4 one time with 1 left over, and it goes into 12 4 times. And our last problem is going to be 16 plus 14, which is going to be 30. 16, 14, add them together, carry the 1, 30. All right, so my suggestion for you is make sure that you guys take these things one step at a time. Our last problem to talk about, I already showed you all the work for this one, but again, looks extremely complicated, but I'm going to simplify everything one step at a time. Our exponents on the inside become this. Our absolute value is going to be -2. The square root of 16 is 4. This absolute value of -2 is 2. I do my division first, and I get my answer.